All right, hello. So I did my project on exploring the physics of pacemakers. I was personally interested in this topic because my grandmother passed away from a malfunctioning pacemaker, which sparked my interest in understanding how these work and exploring how pacemakers function and how they can malfunction. I think this is important because pacemaker prevalence is extremely large in the US. And it's important to understand how these function to be able to properly treat patients without complications, as a more vulnerable subset of the population is generally the people who are getting these devices above the age of 65. So what is a pacemaker? It's a small electrical device, as seen here, that's typically implanted in the body, typically below the collarbone, to regulate heart arrhythmias through electrical impulses. It has two main functions: to sense and to pace. And it senses when the heart is beating too slow and sends signals to correct the rhythm. So it's often used to treat bradycardia. As you can see, the top here is a normal sinus rhythm. We have much more frequent waves. Bradycardia, much more spread out. And it's a condition where your heart beats fewer than 60 beats per minute. It's problematic because your heart is unable to keep up with your body's need for oxygen. The electrical system of the heart. So impulses travel from the SA node, which is your heart's natural pacemaker, into the right atrium, and the impulse continues down an electrical conduction pathway. These stimuli cause muscle to contract and pump blood to the body. So one of the first categories I'm going to be looking at is the investigate category. So the components of the pacemaker, we have the pulse generator, which is made up of the battery and the electrical circuit. And then it's attached to these leads or wires, insulated wires that connect the pulse generator to the heart chambers. And it's inserted through blood vessels. This delivers impulses to the heart and senses the heart's electrical activity and relays that information back to the pulse generator. The pacemaker itself is like a battery, which is connected to the heart by way of leads. So the pacemaker should be capable of outputting an impulse between 0.1 to 15 volts up to 300 times per minute, lasting about 0.5 to 25 milliseconds. And the pacemaker rate, pulse width, and voltage can all be controlled and programmed by a human being. So looking at these models of physics, here's pacemaker circuitry. So we see like the pulse generator kind of broken down into a bunch of multiple mini electrical circuits. So you have a sensing circuit, a processing circuit, communication circuit, logic and control circuit, and the output pulse generation circuit. So the pacemaker battery is like the power supply, and it has some voltage. And the pulse generator generates electrical impulses, and it can be created or modeled using a combination of resistors, capacitors, and transistors. The timing circuit controls the pacemaking rate, and it can be modeled using a resistor capacitor circuit. And then the output circuit is what delivers the electrical impulses to the heart. And that could be modeled as like a simple LED, which has some resistance. And then we also have the sensing circuit, which detects the heart's natural electrical activity and adjusts the pacing rate. So if we were to attempt to model a pacemaker as a series of circuits, this is essentially how we would break it down. And then this is another example of a pacemaker circuitry that a researcher from Northern Michigan University came up with. As you can see, we've got some voltage source, maybe that's a battery, some resistors, some switches. So some basic circuit components that we have actually worked with in physics 2 this semester. Some questions to consider and potential avenues for investigation would be: what would be the impact on the heart if something like the sensing circuit was malfunctioning? Or what would the impact be if the output circuit malfunctioned? And I would hypothesize that, well, if the sensing circuit malfunctioned, it wouldn't be able to detect the heart's rate. And then if the output circuit malfunctioned, it wouldn't be able to actually give the heart what it needs and correct the arrhythmia. Another question: how does the electrical stimulation compare when different voltage batteries are used or different forms of resistors? And to do this, we can actually use Ohm's law with that relationship between current and voltage. Looking at the create category, I drew this. So I was inspired to do something creative and decided on creating a piece of artwork that depicts where one of the leads of a pacemaker would be inserted in the right ventricle of the heart is where you see the clock. And then the film in the background represents the passage of time of someone's life. And the red heartbeats are supposed to represent a bradycardia sinus rhythm, and the green is that corrected sinus rhythm, normal sinus rhythm corrected by the pacemaker. And then the hands are essentially representing like human intervention in the physical body and how the pacemaker is ultimately programmed and controlled by a physician or someone who's programming the pacemaker. So essentially, this person's life who has this pacemaker is controlled by the human's intervention into their body. Overall, I wouldn't consider myself to be very artistic, so it was a bit challenging to get myself to think of this concept creatively and execute it. But overall, I'm really proud of myself for giving it a shot and thinking about how this project relates to my personal life and my personal interests. Looking at the sociocultural significance, it connects to the broader cultural idea of physicians being responsible for human lives by having the ability to program the settings of a pacemaker. And so also physicists also have a strong component of responsibility with this, as they are the people who are programming and designing these circuits and these different components of the pacemaker. And then here's my class problem and sources. Thank you.